All right, transforming other functions. We just spent 3 videos talking about how do you transform quadratics, how to use them, how to model with them. And now what we're going to do is we're just going to jump over and we're going to talk about every other function. So here's what we discovered, that if I want to transform the parent graph y equals x squared, I can replace the x with x minus h. That causes a horizontal shift of h. Be careful there. That x is in fact, excuse me, that minus tells you that it's the opposite of what you might think it is. X minus 2 is to the right. X plus 2 is to the left. I can add k. Well, when I add some value to the end of a function, all it does is change the output value by that much. So that's a vertical shift. And if I want to stretch or compress the function, I just multiply by a stretch factor, which would be some number greater than 1, or a compression factor, which would be between 0 and 1. So how does that generalize? If you were in my class, we'd spend a few days playing around, we'd experiment, we'd put equations into the calculator. But what we can do very quickly is that we can generalize this as, if I have some function f of x and I want to transform it, I can transform it by putting a stretch factor as a multiplier, changing the input by some horizontal shift value, and adding some vertical shift value. This is the general form of a transformed function y equals f of x. Let me show you some quick examples. Parent graph y equals x cubed. If I transform this and I write y equals x minus 3 cubed, my graph goes from y equals x cubed to y equals x minus 3 cubed. Y equals square root of x. And the graph looks like this. There's 1, 1. There's 4, 2. Y equals 1/2 the square root of x. Well, now I've got 1, 1/2 and 4, 1. One more example. Pick any random function, doesn't really matter. Y equals 1 over x. I know that this looks like this. I know that it has asymptotes at x equals 0 and y equals 0. Always a useful place to start when dealing with a rational function. Well, what if I write the graph y equals 2 over x plus 1 minus 4. Well, my graph is shifted 1 to the left, which means I'm going to have an asymptote over here at x equals -1. It is shifted down 4, which means I'm going to have an asymptote down here at y equals -4. And it is stretched by a factor of 2, which means that it is going to go up twice as quickly. And essentially, it's going to look like this. I'm not going to plot the exact points because I'm just looking for a rough idea of what it should look like. Steeper, shifted down, shifted to the left than my original parent graph. There you go. There's the basic idea. That's what you need to know. There are 3 transformations. You've got your stretch, compress. You've got your horizontal shift. You've got your vertical shift. I haven't really talked in any of my videos about the reflection so much. Put a negative in front of it, reflects over the x-axis. Haven't talked about a y-axis reflection because we don't cover that generally in our class. That comes later. All right. Hope that helps. Thanks.